This is 110, number 22. It's one of those show problems, so I like to show that the left-hand side is equal to the right-hand side. I'm going to kind of like look at the right-hand side a little bit and see if I notice anything. I noticed that cosecant squared x, there's a couple things that I could do with cosecant squared x. One of them is, I think I got a Pythagorean identity for cosecant squared x. I think cosecant squared x can also be written as 1 plus cotangent x. So I don't know if that's ever going to, if I'm going to end up using that or not, but I just kind of like to look around. And also cosecant x, isn't that 1 over sine? That could be written as 1 over sine squared x. So just keep those in mind as we look at the left-hand side. So sometimes you just have to blindly start trying stuff. Does anyone have any ideas of something we should start trying?
Get rid of that 2.
Get rid of the 2? Well, usually what we want to do is start doing things, manipulating the left-hand side. So a lot of times it pays off to get a common denominator. That might be an idea that we could try, unless we recognize anything else about it. I don't see any real other identities that I recognize. Like I'm looking at, yeah. So how about we'll try doing a common denominator action on here. Hopefully this works out. So the common denominator would be secant. Did you get anywhere?
Yeah, I did.
You did? What did you try that got you somewhere?
First I made them together, like what you're doing.
Uh-huh.
Like combining like terms. And then cosine times secant is just 1.
Oh, yes it is. Okay, so I'm on the right track maybe?
Yeah.
Okay, so we'll keep going because okay, that is very, very comforting to know that we're going to get somewhere by doing this. And so that was just a hunch, because a lot of times just the way that the author has these designed is if you usually have separate fractions, you want to try to get them the same. Okay, so we think this can... So cosine times secant, because they're reciprocals, that equals 1. 1 plus 1 is 2 minus 1 minus 1. I'm going to mess up my signs on the easiest thing, huh? This will be minus 1 plus 1. Does this just turn out to be a 2 up here for you?
2.
Because doesn't that go...
2 cosine x. Because you have a negative cosine x times the negative 1, and that'll end up being...
Oh, yeah. Okay. So, tell me again what you got, because now my brain is fried.
2 cosine x.
2 cosine x, okay.
Or 1 plus cosine x minus 1 plus cosine x.
Yeah, because this is 1 plus cosine x, and then that's minus 1 plus cosine x, and the 1 minus 1 go away. I got it! Okay, so that's kind of, so we got our 2, and we got a cosine, and did yours already work out? You already finished it up?
Yeah.
Did you just square, you went like, this is secant squared x down here, is that?
Squared x minus 1, yeah.
Secant squared x minus 1, and then we know that secant squared x minus 1 is tangent squared x. Okay, so, man, secant squared, that's tangent squared x, but we know that tangent squared x, where am I going with this, is yes. Hey, let me do it like this. Sine over cosine, but then when I turn it upside down, it'll be cosine over sine, right?
Mm-hmm.
Oh.
Yeah.
Yes, thank you. Okay, and so then I keep looking back up here, I'm not bringing it down with me, but this should be coming on along down with me. And that's supposed to be equal to cosine cubed x squared x. We're just finishing, I know you're done, but we're going to finish it out for if anyone at home wants to see it. So then that's cosine cubed x, and sine x in the denominator, if you bring it up, it's cosecant x. So I guess we're done, aren't we? 2 cosine cubed x, and then the sine x turned it into, because like it's sine x over 1, and then it comes up here, it's 1 over sine squared x, but that's cosecant x. Feel kind of clever when it works out like that. And we just know that there's as many ways to do it as there are brains to think about it.